This is my linear regression application. So we'll start with a base sample size of 30, a mean of 0, variance of 1, and 1,000 simulations. And as you can see, this is the generated plot and the histogram. So let's modify the sample size first. Instead of 30, we'll do 100. And we'll keep everything else the same. So as you can see, there's many more points because we're using 100 instead of 30. And you can see the regression line became more stable. It's less affected by individual points. And with more data points, we get a more clear picture of the pattern. So now, instead of comparing sample size, let's look at the variance. So let's see, let's try with our original sample size of 30, mean of 0. Instead of a variance of 1, let's do variance of 0.1. And then the same number of simulations, 1,000. So so you can see the generated plot here. And here's a histogram. We'll see after when we do the higher variance, but it seems like the points cluster closer to the regression line with lower variance, because the noise in the data is going to affect our ability to estimate the relationship. So let's check with 4, which is 4 times the original, and 1,000, sorry. So yeah, as you can see, with higher variance, the points are gonna scatter much more in the vertical direction away from the regression line. Yeah, this just shows how the noise affects our ability to estimate. And yeah, so we can see how the sample size and variance affect our regression estimates. Basically, larger sample sizes will give us some more stable estimates, and higher variance would make it harder to detect. You could say valid or not valid, true relationships in the data.